big slurp today. Hey up everybody, welcome back. As you've gathered from the title today, we're going to cover a topic that's quite elusive in the home workshop. If you've got fancy CNC machines, then these are quite easy to produce, but if you're like us at home with a manual machine, then these are probably one of the more difficult shapes to manufacture. I'll bring your attention to the humble sphere. Now, I don't really have many in the workshop, and there's good reason for that, because again, they're difficult to produce. For the few that I've got, we've got obviously drill handle ball. We've got a couple of them flat ones with holes in. Normally got quite a few of them kicking about, and then we've got stuff like this that we've rounded the ends of things to manufacture punches or form tools or something like that. So casting them to one side, obviously that's what we're really talking about today, the sphere. So what makes this shape so difficult to replicate at home? Well, for starters, as I've said already, not many of us have got CNC machines. So trying to replicate this on a manual machine is tricky, to say the least. Also, don't really have a vast use for them. And when you've only got a lathe and a milling machine, do you really need to produce a lot of them? No, probably not. We've all seen them, we all know what they are, but what makes them so tricky? Well, for starters, if you've got a lathe, then you know that a lathe is very good at creating cylindrical objects, specifically parallel ones, when you're using travel and feed. It's really good at that, but what it isn't so good at is if you've got a cut on, you can't deviate necessarily too much off that cut to manufacture something that's got a bit of shape like this. Now, there are ways and methods of doing that, obviously. Like I sort of touched on it, we've got form tools and there are radius tools that you can put in the tool post and remanufacture that. But we haven't got any. I could make a form tool, but your form tool is only as good as the person that's making it. So if you haven't got something round to make it against, then you can't make a sphere. But what we can do is a bit of sort of manual machine magic. And there are ways of reproducing these with a manual machine, and that's what we're going to show you today. Okay, so briefly, before we get started then, we'll try and keep this bit as short as I possibly can, because those that are allergic to maths might want to skip a few minutes. I am really sorry to say, but this method unfortunately is really heavily dependent on doing some relatively simple calculations when you break it all down, but the formula required is, well, it is the thing of nightmares for some people. So what we're going to be looking at today is quadratic equations. I cannot believe I'm saying that, because I remember all them years as a young boy, sat in the classroom, teachers pointing at the board going, right, today kids, we're going to be looking at quadratic equations, and obviously everybody's sat there going, well, I'm never going to use this again in my entire life, and look at us now, here we are. So I'll drag this in anyway. So this is the formula that we are going to need for this. It's a way of generating a curve in X and Y, or X and Z, whatever you want to call your axes. So obviously we've got X and Y, but what we do is we put the radius into the equation, we tell it what coordinate we want in X, and out it spits a coordinate for Y. So the actual calculation bit is quite simple, because you break it down, you do that bit first, and then you do that, and you square root it all, and out it spits a figure. So it is quite straightforward. But there are a couple of considerations to this that we need to make before we sort of worry too much about what those figures are. So I'll bring this other drawing in quickly. Now it's on blue, just to keep things interesting. But this is what we're basically trying to do, is that we want to create a sphere. Now in this situation I've decided it's going to be a 30mm diameter. But that's not all we need to know. We need to know the diameter or size or whatever tool that we're using, because it might just be that we're doing half or we're doing a full sphere, so whatever. In this example I've got a 12mm round button insert indexable tool, and the idea is, because I'm using this, I can get all the way around. Because if I were using like a right-handed tool, you'd only get maybe 2/3 the way around before you start cutting on the back edge of the tool. So we're using round because we'll get all the way around. So if we want to produce a 30mm diameter sphere, we need to add the radius of the sphere plus the radius of the center line of the tool as well. So because our button tool is 12mm, in total we'll have 15 plus 6. So the radius of the swing of the tool will actually be, what's that, 21mm. So the center of the tool needs to be on a arc of 21mm from the center to produce 30mm diameter sphere. Obviously if your button tool is bigger or smaller, then that distance will change slightly. But all that needs putting into the calculation, because you need to account for that, otherwise you'll get an incorrect size sphere. So again, for anybody that is allergic to maths, there is actually a way of calculating this if you're any good on the CAD type software. So what I've done is I've used a slightly different size because I intended this to be like a roughing cut and then that 30mm diameter to be a finishing cut. But it serves no difference in that obviously just the diameter's changed slightly. In this we've got a 32mm diameter sphere. We've calculated that we need a 44mm diameter like sweep of the tool because it's 12mm button insert. And what we can do is we can mark off increments on one axis and then measure the other one relative to that. So if I grab a pen so we can see a bit more clearly. So our first cut, obviously 0, 0. The second cut will be, I think I've done it in 1mm increments here. Maybe 2, I can't remember. I haven't marked that off. Possibly 2. So a second cut will be out by 9.17mm and in by whatever distance I've calculated it at. I should have put that on. So apologies for missing that. But all we're doing is we're measuring off. So we've moved. This is our sort of as in. So when that line intersects that line, then we can measure that height, and that'll tell us where the tool needs to be in its second cut. So you can keep doing that. You can have regular increments of cut width or distance, and then just measure off each line on this software, so you don't even have to do any maths. And if we tally that up with the chart that I did calculate using the maths, we can see that as first cut it was 2mm obviously. So we need to move that way by 9.17, which is 9.17 on here, and then in by 2mm, and then as next cut is out to 12 and then in by 2. So that tallies up with that. So that was done on drawing software. This was done using the quadratic equation. So you can see that the two figures align and the formula is correct. So that is the one way of proving as well that you've done everything right, because that's always nice to check. Trouble is, you wouldn't want to do that if you had a really fine feed. For example, say you were doing 0.5mm increments, so in this axis every feed was 0.5mm out, then you would have obviously 4 times as many entries in there, so you get quite crowded. But anyway, this is our sort of our cheat sheet, if you like, and I'm going to go through that now. So there's a quadratic equation formula, and all I've done in this is basically broken it down in Excel so it can understand it, done it in stages, and it spit me out a set of coordinates. So we've got X and Z, obviously X and Z on a lathe. 0, 0 is our start, but I've done it slightly differently because it's easier to read off a DTI then, because that's what I'll be using to set the cuts distances. So if we look through this table, we can see our known axis, our known distance, so 2mm increments in this case. Just put that in there and it'll spit out its corresponding axis on this curved graph. So for 2mm out on a 36mm radius sphere, so using 12mm button tool again, the effective radius of the tool and the sphere will be 24mm. So that's been put into this, and it gives us, say, his first cut 2mm in one direction and 9.59 in the other. So it gives us a nice breakdown of where we need to be and where we need to move the machine to. What I've done in here below is like I said, I've broken it down and converted the figures into sort of figures I can understand on a DTI, so I don't get confused. So these are our X coordinates, which we calculated in this end column, and this is a Z, which I've done relative to a DTI. So we start at 24 and we drop down to 0 and then reset to 24, because obviously we've only got like 25mm travel on a DTI. So I hope I've sort of made a little bit of sense there. It is difficult to try and explain. We'll see more when we get onto the machine. We'll see why this works and how it produces a sphere. But we'll jump on there now, we'll get some material set up and we'll work through these figures and try and produce some akin to a round object. Right, so we're over on the lathe. Hopefully you'll all forgive me, I have already had a go, but I did cock the first one up, so you'll not be seeing that, but hopefully this one will go better. Basically what I've done is I have machined a known diameter to the outside of this aluminium bar. Now we're using aluminium because it's a bit easier to machine than steel. So machine that to a known size, which means I can calculate where the centre, the very dead centre of this is. Because obviously with the round button tooling, which you can see we've got, it's difficult to gauge where the true centre of that tool is in relationship to the centre of the workpiece. So you can just see this DTI in the bottom. I've set that up already, like I say, so that is already set at its 0 point in the X direction. What I do need to do is face this off, get it somewhat clean or cleaner, and that'll be my new Z 0 point. So I'll be able to set the other DTI up on the other side, and then I can work off the figures on the chart and that'll tell me where I need to move the machine to. So we'll quickly get on that and get set up ready to go. Right, so what we're doing there is I was just checking that this is in the correct place, basically, because having had machined it already once, I wanted to ensure that the detail reading right and that it was actually at its, well, where I hoped it was. So we've got 37mm outside diameter on there, and we've got 12mm insert, so we need half of both of those added together. So 37 plus 12 is 49, half of 49 is 24.5. So we're not far off. I'd say that's still as good as it was before, so we're happy that that's in the right place. I can touch on the end of here now, set my other clock up, and we'll be ready to start. So the first sphere will be a roughing cut, so we've got 2mm increments. So we're gonna come out first, and then we're gonna go in by 2mm, then out and in. And then when we get to the other side, we'll have to make sure that we go to the chuck first by 2mm past where we need to be almost, and then in, otherwise we'll get a sphere that's not quite round. It'll be more like a spheroid, they call it, a flat sphere. As you can't see the DTI, it's just down here. That's set at 24mm now. We've got this one that's set at 0, obviously 0 when we wind all the way in, which is there. So off our sheet, like I say, its first move will be out to us by about 9.5mm, and then it'll be in by 2. So we'll come this way, 9.59 I think it was, and then we'll drop down on the other DTI to 22mm. Right, so that's his first rough cut done. So the first half of that sphere. And I think you'll agree that well, from my perspective, that looks pretty good. I'm not sure quite what you'll be able to see there, but I'll move the camera around and we'll get a slightly different shot for the next bit, so at least you can try and see a little bit. So as I was saying now, so we've got to 24 on this clock, within a couple of hundredths, and we're at 0 on the other DTI down here. So what I need to do now is reset that to 24, move out 2mm to 22, and then I'll be able to go in on this one. Otherwise, if I do this first like I was doing in that time, then we'll end up with a sphere that's flatter than it should otherwise be. Right, so there's this sort of a rough sphere. Now, apologies if you didn't see all that. I noticed that that was in the way actually, so I moved the camera around, of course. But for a 2mm feed, I think you'll all agree that that actually looks relatively good. I mean, if we throw a vernier over there, I bet the accuracy is pretty decent. So we try not to measure into a trough. 29.25 in that, sorry, 36.29 in that direction. Just under 36 in that direction. So it's not quite spherical in like its longest. I mean, that could just be slight accuracy on the long travel. The actual OD is where we needed to be, about 36. So what we can do now is reset this back to the beginning. We'll do the sort of finish pass at 1/2 mm increments and see how that looks when we're finished. I've got my next page set up now. Find somewhere to put it, that'll do. So we're at 0, 0. Hopefully the camera don't shake about too much. Apologies if it does. So we're at 0, 0. So my first cut will be obviously an out, an X, and then we'll go along with a Z. So 1/2 mm increments this time. It's a lot smaller than it was before. So we've got a new target as well. So we're in every 1/2 mm. So my starting point now isn't 24mm like it was. It's going to be 23.5 because finish size of this we're aiming for 35mm. There we have it, albeit with a little bit to take off of the bottom there, but we'll take this over the bench and we'll have a measure and see how it looks, see how close we got. Right, here we have the finished product then. I hope it comes across on the video, but I'm absolutely chuffed to bits with the results of that. I didn't think it'd come out quite as good as that. Now, we could argue that maybe the surface finish is not quite as good as we'd expect. Certainly not as good as a CNC machine. It kind of reminds me of one of them old cotton wrapped baubles, you know, that's on your grandparents' Christmas tree. But obviously we're using a tool that's probably not the best tool for the job. We're on a lathe that's 70-year-old and tired. Plus we're using a couple of DTIs and we've not got digi readout or anything. So with all those factors stacked against us, I think we've done a pretty good job there. The one important thing, however, is how dimensionally accurate is this? Now, remember we said we were aiming for about 35mm on the diameter. So we just throw a G caliper across there, 35.1. So we're slightly over. I'm not going to argue with 4 thou. I'm obviously for the application that this is going to be used for, you'll never notice a 4 thou oversize on that. Something a bit more dimensionally stringent, you obviously would, but for a handle on a drilling press, we'll let that one go, I think. Checking a couple of other directions. 380809. 3508 again. 09. So in terms of accuracy, over 35mm, we're getting a total error across various different measuring planes of 0.02 maximum error. Now, on something that size, as I say, we've done it on a manual machine, and we've done it with a couple of DTIs, and obviously hand feed, hand travel. That's pretty good. You've got to be quite impressed with that. I certainly am. Didn't think it'd be as accurate as that. I'm pretty happy. I hope you can hear. I hope that comes across. I'm pretty happy with that. You'd be hard pressed to do much better, I think, on a CNC machine. Obviously, these super modern fancy ones would blow that out of the water. You get perfect surface finish and dimensional accuracy to within a couple of microns, but 0.2, 0.1 of a mil hour tolerance is pretty good going. If for anything less than sort of 0.4, 0.5 on a manual machine, you've done all right. So to be 0.2, total error on that, yeah, we're happy with that. So I hope you've all enjoyed that. I certainly did. Didn't think that that would be as successful as that, especially based off my first attempt, which is here, by the way. Not quite as good. Although surface finish is slightly better. It's not quite as good. It's not circular. It's a bit flatter than it should otherwise be. But in terms of that, really happy with that. Proper successful job with that one. So yeah, like I say, I hope you've enjoyed that. Thanks for watching. From York's Fab Shop. See you next time.